Hello and welcome. Today we will learn about structure of discrete time signals. So basically there are four types of structure we will study. First one is DF1, direct form 1. This is the first structure and this is the second structure. These are the first two structure we will study, and the next one are cascaded and another one is called parallel. So our main concern today will be on these two. So we have this transfer function equation written and in y of n form also. So we will look this y of n equation and make our structure. You know how to get from h of z to y of n. It's very simple. Just break this h of z in y of z divided by x of z and do cross multiplication, and next it is easy. So now I will make the structure. What is your input? Your input is x of n and your output is y of n. So I will make the structure here. So this is your input and this is your output. Okay, so now input is getting multiplied with factor of v naught. We will multiply it and apply an addition, because it is getting add after, because this xn and v naught they multiplied, they become v naught xn. Now join this. Okay, it is y of n. Now you can see that there is a first delay because that delay comes from this, so it becomes y of n minus 1. Then it goes and it is multiplied with a1. You multiply it and again we will make an adder. It is getting add and after getting add it is getting into this one. So this is your a1 y of now we have to do similar for y of n minus 2. Again add a delay will be 0, z minus 1 not minus 2. So what was it? It will become y of n minus 2, and it is getting multiplied with a2. And then it is going into that same adder, and it is a2 y n minus 2. So our structure has been established. I hope you can understand. See this equation, we have input xn multiplied with b naught, we multiplied it, then it is getting add, we applied an addition sum and make a straight line till y of n. In y of n there is a delay y of n minus 1. Here it is getting multiplied with a1, sum this one a1 n minus 1 and it goes here. Then again delay, it becomes y of n minus 2. Here it is multiplied with a2 and then it goes here. So this is neither DF1 and DF2, it is a simple structure, but now we will make a DF1 and DF2 realization and it makes the case more easy. So let us take an example. We will solve it using direct technique. It is 1 plus two z inverse and then it is 1 minus 1.5 z inverse plus 0.9 z minus 2. Now I will use the technique of DF1, which is a straight technique. Again make a straight line. This is your x of n input, and this is your output y of n. Now first you have to draw zeros. In DF1 we draw 0. Make a box. See how many delays are in zeros. There is only 1 0. Means see how many delays there are. There is only one delay. So delay is equal to number of boxes, and always move this constant and always place this constant on here. Okay, then make a delay. There is a delay of z inverse 1 and it is getting multiplied with 2. Okay, now for poles again place that constant and there are 2 delays, so there will be 2 boxes. So there are two boxes. Z minus 1, and it is going in, it becomes 1.5. Then another delay, and now I will place minus 0.9 because it is a positive feedback. So here that's why I will place a positive, negative number to make a positive feedback. So that's how direct structure DF1 is created, which is quite easy. Now we will make direct DF2 structure. Now I will take an example. So it is 2z inverse plus z minus 2 divided by minus 0.175, and it is 0.25 z minus 2. Now making it structures. Draw a straight line first. It is your input x of n, and your output is y of n. Now in DF2 I will must mention here that it is direct form to structure. In DF2 it is convenient because we get half delays as compared to half delay as compared to DF1. So now we will make poles first. These are not poles but associated with poles, and delay gets common in DF1. It is not common, but it gets common in this case. So now I must make it a bigger picture. delay gets common between two, and we make poles with denominator associated with it first. So your first delay and then second delay. Now in denominator we are making, so it is minus 0.75, and here we also have a constant 1. For next step we will put minus 0.25 and here. Now we will make numerator. In numerator we have 2 here and 1 here. So that's how you create DF2 structure. Delay gets common denominator first and then numerator. In DF1 structure, this is your DF1 structure. This is a DF1 structure. In DF1 you make numerator first and then denominator, and there is no common delay in this case. In that DF2 or you can say the delay gets common up, and this is a single example, means it is not a direct form. We have to make the block diagram. It is type of a block diagram, and DF1 is a direct way and DF2 is another method. That's all.